All right, so good morning, Morgan. And are you able to hear me clearly? Yeah, I'm sharing the screen. All right, so a quick do you have any questions to me before we start the session? Okay, okay. So, any questions on Spark before we start the session? Yeah? No questions? Do you want me to recap a bit or should we continue? We'll have sufficient time today, no worries. Okay? All right, no questions. So, should we? Okay, okay. Yeah. So, I know few of you could not attend last time, and let me do a quick recap. We'll have sufficient time today, no worries. And all right, so we discussed about Spark last time. Spark is again a distributed computing tool. It does not provide you it does not provide you any kind of hard disk storage like HDFS or a database. It only provides you a compute engine. You load the data from somewhere, you start doing the computation. That's all Spark is all about. And it does the computation using using multiple nodes parallelly or multiple computers, and it can run standalone, which is generally for testing, not for real life, or it can run on yarn. So utilizing the resources of yarn is what Spark would do if it is running on yarn. And it can run on Mesos. Mesos is again another resource manager, and it can run on Mesos. And there has been multiple kind of libraries written on top of Spark, such as similar to what we studied Hive. People have written Shark for Spark. Okay, and machine learning libraries similar to Mahout, and even Mahout is being ported to Spark. Similar to Giraffe, GIRAPH, that's a graph processing library. You have Graph X here on top of Spark, right? And there's a Spark streaming, which is a new thing which was not there in earlier. So we'll discuss Spark streaming also. So you can install it or you can simply run it like this. Okay. And so you can take this command and run it, and you'll get the command prompt. Command prompt is nothing but your Python console having one extra object called SC. Using this SC object is your gateway to Spark. All right. So there's sort of you can think of it as a library, or you can think of it as a gateway towards Spark. So PySpark is basically a Python command prompt, and using this you can do. Let me SSH. Okay, and once you run PySpark, you can basically do anything you can do in Python plus on Spark. And the basic concept in Spark is resilience distributed dataset. Basically, you prepare a representation of your data as an array, as a big array. Some part of this array is on one node, some part on another, another part in another. So this resilience dataset, say 4 nodes, this is distributed on 4 nodes, for example, it is loaded from HDFS. Okay, so it does not mean that it's basically consuming, putting everything into memory, but most of the time resilience distributed data set is in the memory. All right. Across the processes, if you want resilience data set to access, you can persist it, keep it in the memory, and in case one of the nodes fail, then the node is quickly replaced with some other node. All right. And generally it is like an array, but each object can be of key value type as well. All right. So if you have to load a file, if you have to convert your HDFS file into an RDD, what you do is you ask this SC object saying, this is my big.txt file, can you load it? So lines is your RDD representation of HDFS. Now on top of lines you can do many kinds of operation. So there are two kinds of operations in Spark. One are called transformations. Transformations solely run on each node, and transformations do not execute until and unless there is an action happening. Similar to pig, unless you say store or dump, none of the operations happen. So in Spark, similarly, transactions do not start execution before an action is executed. As soon as you execute an action, transformations start. There are many kinds of transformations, such as map. You using a map transformation, you can apply a function on each of the elements of an array, each of the element of your RDD, which is, you can imagine an RDD like a humongous array. And map function, you can think of map function as something like a a distributed version of for loop. Okay, so you take this function and apply on each element of this function. What does it mean by applying? You take this function, execute this function by passing the argument, passing the current object of the array as the argument, and whatever is returned will create another RDD. Okay, so a map would effectively return another new RDD and having equal number of objects as the actual one with the one which has been transformed. All right, so function takes a single argument. Then filter is another kind of transformation which will only allow which will create a new resilience data set with only the element which pass function. So function returns true or false. Each element is tested against this function. If this function says true, then Filter puts that element into the new resilience dataset or copies this element to the new resilience dataset based on this function. Now, this is a flat map. Flat map basically generates key value pairs. Instead of single value, it generates each element becomes key value pair. And other quality of flat map is it can generate either it can generate any number of key value pairs, just like our usual map reduces map, Hadoop's map. So there our map function could generate as many key value as it wanted, but here the map function was strictly generating one output for one data. Here, flat map is exactly like our Hadoop's map. Now, so which means one element can generate zero or more new elements for the new RDD. Group by key is another transformation which groups our data by particular key, and this key is generally generated by flat map. All right. Now, then there are actions. Actions basically gather the data from all the RDD. Actions make all the transformation on which an action depends are executed as soon as an action is executed. Just like when we say dump in pig, that makes all the elements on which this dump depends upon get executed. Okay. As soon as you execute dump or store on a particular dataset, all the elements on which this dataset depends will get executed. Similarly, an action is such a thing which makes everything before on which action depends, all the transformations on which action depends will get executed as soon as an RDD, as soon as an action is executed. All right. The other part is which you should understand is, so in the beginning you will load your data just like this, which is the phase where we create an RDD. We took a local variable and we told Spark that can you create an RDD on top of this particular file, this data, and then you apply transformations. And the moment you run an action, it converts your RDD back to your local data. It brings the remote data to the local node. All right. There are many kind of actions provided by Spark. Here are few of them. One is reduce. Reduce, just like your combiner, takes two argument and returns a value. Instead of like in combiner, a combiner could take multiple values. Here, a reduce only take two values, and reduce function is applied recursively on data unless the whole data is reduced to a singular value. All right, so that's a reduce function. So the way we say that we define a function, we create a function, we pass the argument of the function, and reduce is a function in the RDD. So we created an RDD called lines, and on top of it, we run this function, and then we do the count on elements. And so I'll show you a little bit more. I think this would do good job. So let's take this particular thing. Okay, so is everyone with me? All right, so I just launched Spark. All right, this is a Python command prompt, and Spark context sc is the one which is our gateway to Spark. Rest of the things is plain vanilla Python. You can do everything your Python can do, except you have got one extra object. Now, let's say we got this array and we want to convert it into RDD. So we call it lines equals sc dot parallelize. All right, we call it sc dot parallelize. Now, if you see, lines is now RDD. Okay, and so let's say we want to count the number of characters in each line. Okay, so what you do is we create a new RDD. Now let's name our new RDD as LL. LL is equal to our the previous RDD was lines dot, and we say map. And here we are passing a function called len. What does len do? Length. This is a length function. So if you see this function len and you give any string to it, a single string, it gives us a result as length of the line. So what we did here is we passed len function, length function to our map our map. So what effectively will happen is this length function will be executed on each of these. All right, on each of these. All right, and now lines, if you see, if you want to see lines, you can say so not this ll. We want to see the all the line lengths, so you will have to collect them or you have to take them. Take or collect will bring the data from all these nodes to local node. This is an action. As I was telling you here, other than reduce, there is count, collect, and take. Okay. Similarly, ll.count says there are 6 elements in the array. And if you want to do something of the sort that now on top of it, say we want to sum up all the line lengths. Now ll is our RDD. It says it's a Python RDD, and we can say RDD dot collect. So it will bring all the elements to local machine. So these are the elements containing in LL, and the elements contained in our lines are these. Sounds good to you? So we had this big array. We converted it into the length of each element, and effectively we have line lengths in this. Now if we have to sum up all these line lengths, we can define a function mysum. Okay, so we can define a function called mysum, and it it's a reduce function which we're planning to do. Mysum takes two arguments, x and y, and returns x plus y. All right. Now, just to test what is mysum doing, so I pass 3 and 4, and you get 7, or whatever you want to do, you can do with this. Okay. Mysum is a usual Python function. All we next, what we want to do is we want to say ll dot reduce and use mysum to aggregate each two values into one value. That's what I'm trying to say here. So all the elements from LL will be summed up recursively until we reach to a value. So the answer we have gotten is 58. Okay. Here we have got 58. So we have summed up all the values of this and we have got the answer. All right. Sounds good to you? So it gives you far more controls over the transformations and everything. Other than that, Spark provides you broadcast variables. Using broadcast variables, you can broadcast the values to all the nodes. At the same time, each node can communicate to the other node using broadcast variable. All right. Then there are accumulators. Accumulators are essentially a one-way direction of collecting data from nodes continuously. So each, say for example, you want to count numbers, how many, what is the progress currently. So you can create an accumulator and keep on, where each node will keep on pumping the data. So accumulator is one way, and there could be many accumulators in your program. Sounds good to you? Okay. So let's define a function which takes a line and lines dot flat map. Yeah. So return line dot split. So what does this thing do? All right. Now let's apply this flat map over our lines. Not this. I say lines. Oh, sorry. Lines dot. Just a second. Just a second. I have given the name of the function. So let me just define my split. And whatever we pass here, it should basically return line dot split on top of it. So my split essentially good. So next is what do we want to do? We take f equals whatever lines we had, we are saying flat map, flat map my split. Okay. Now f dot collect, if you see what would we have in this, we'll have a big array, okay, containing one word. Are you with me? So we have splitted our array. All right. So all we did was we applied a flat map, or let me just do it a little bit different. So let's import the regular expression package. Okay. Then let's load our word count example. Okay. So instead of loading the things from memory, this time we have loaded it from HDFS. And our lines basically contain all the lines of this text file. Okay. Now, if you want to see what is there in this, you can say take 50 values. Okay. And then it will show you that it essentially contains an array of lines from that file. This is an array of lines. You can see that from square bracket till square bracket. It's an array of elements. U means Unicode, and from here to here is each line. All right. So lines we loaded from our HDFS. Next is let's split this one word. One word. Let's convert this array of lines into array of words. Okay, so that each element of the array is a single word rather than a line. So what we say is we run flat map on lines. We say words equals lines dot flat map and here we say my split. My split converts a string into words. Okay, sounds good. Now if you say I say words dot take 10, it'll give me 10 words. Okay, so if you can see this, and now next is we convert it into a very simple next is we convert it into a key value pair by using our map function. So we define two key value, one of the arguments. Okay, and here this function basically converts anything you pass to it into a key and one. All right, so two key value, and let's just test it quickly. So it says send and one. Now if we apply this map function, so we will say words kv. This is our new RDD which we are trying to do, and on top of words we want to say map. So each value of words, which is basically a single word, will be converted into word comma one. All right. So we say 2kv. So each element, this function is being applied on each element, and what does this function do? It converts a single value into key values, where value is 1. Now you can see that words kv dot take 10, and what does it say? It has converted each word into this format, right? Next is we can say another transformation which says that reduce by key. Okay, my sum, if you remember my sum, what did my sum did? My sum summed up two values. That was our function. Now what we'll do is we will execute reduce by key on top of words key value. This is words key value. Okay, what does reduce by key does? Reduce by key basically does what group by does. Okay, so we say reduce by key, and we pass our function mysum. Okay, ideally we should be doing it the other way. Okay, let's see. Okay, this will be word count. All right, now let's see what is there in the word count. All right, so it has started summing up things. If you want to see all the data, you can see simply all the data, or you can also save it somewhere. You could also save it to a text file, and let's say Spark Fab 21. No, yeah. So we're saving our result into this text file. Sounds good. So from the web interface, we can see whether the file on HDFS is created or not. So what was the folder where we saved it? Our folder was here. All right. So it has done the word count for us. It has done the word count for us. Sounds good? Not sorted, yeah. It is not necessarily sorted. So was this example clear? I have avoided lambda expression here. Instead, I've created this as proper function and then passed it here. Similarly here, I have not cleaned up data by replacing non-alphanumeric. That you can do it by yourself. So the way you have in any language, you can create a separate class and then pass it, or you can create an anonymous object or a function quickly. Similar to that, this lambda is a way to create anonymous functions quickly. All right. The way in JavaScript you have new function, and in Java in Java you have new abstract class name, and then it will give you all the options to then you can override the function override various functions of the abstract class. Similarly here it is lambda. Okay, so make sense to you, or if anything is not clear you can ask me now. So everything is clear to you, is it? Okay, I'll wait. Good. Puneet, Rohit, Roshan, Sham, Srinivas, Murugan, Chandra, Prithvi. All right. So please try it out. It is a technology which is going to. Yes, this approach is easier for a couple of reasons. First, you are not strongly restricted by single map, single reduce in one job. Second, the overall execution is faster. From the development point of view, also, the development is also faster. And it is fairly smooth process when it comes to the development in Spark. Okay. So if you have any questions, let me know because this is a little important topic. Okay. Industry is adopting pretty fast. So most likely, since as of now, MapReduce is used only if you have bad jobs, background jobs where you don't immediately need feedback. Spark will be used in the cases where you would require the immediate feedback. Do it immediately or fail, that kind of attitude. In case of MapReduce, the traditional one, the attitude was do it however possible, but get it done however possible. Okay. I don't need immediately. The attitude with respect to MapReduce of Hadoop was I don't need immediate results. You just get it done howsoever possible and let me know. Here it is get it done now. I will wait as you are working on it. That is the attitude you carry when you're working with Spark. Okay. Do it now, even if you're failing, just let me know. So while MapReduce is for obscenely big data, although Spark also claims it, but Spark becomes a huge memory hog when you try to go for a obscenely big data. Okay. Although they deny it, but the truth is that it's a fairly memory based. And the moment you convert it disk based, they have a way of doing it disk based, but then it becomes horribly slow. All right. So this is a brilliant solution as long as your problem takes RAM equal to the summation of all the RAMs of all the nodes. Okay. Now, if you have to clean it up and you want to, you basically have to avoid the common words. So you can use things like broadcast where nodes are also communicating. There are many ways you can use broadcast. All right. Sounds good to you? Next is the use case of Spark. So we realize that we can create RDD out of any data, and anything that is done on top of RDD is done on multitude of nodes. Okay, or on the nodes where RDD is going to be loaded. So you could do a lot of computing. You could do a lot of computing on top of RDD, resilience distributed dataset. So what people realized that RDD was fairly fast and the computing was also pretty fast when it's in memory. So some of the guys came up with an idea that they will write the Spark streaming on top of Spark. It's an extension of the core Spark API. It has a high throughput and is fault tolerant. So the way any streaming system works is it takes data from high throughput systems such as Flume or 0MQ, Kafka, and maybe HDFS and Twitter. So your streaming application reads data from these messages queues and then generates the output. That's your streaming job too. So the as I told you earlier that when I was with Amazon, we had something called SQSQ, and the system which I built there was based on the SQSQ. It used to read the updates posted by various vendors from SQSQ. So all the vendors, whosoever is modifying their data or description of their product, they will use a thick client or a very good UI where they will make all the changes and then then click on save, and their changes are pushed to a queue, SQSQ, which was organization wide queue, and my code was supposed to read from that queue and process their changes and then publish it accordingly to the Amazon's detail page. Okay, so that's where this streaming came into play. My code was supposed to read really fast from this queue, and my code may be executed on multiple machines. So those kind of examples are streaming examples. This is what streaming is. Okay, do not confuse it with our uh, examples we had provided in Hadoop streaming. That was mainly to stream to pass the data through a program. Okay, so don't confuse Hadoop streaming with this. Streaming is a general concept of doing really fast processing on top of any of the message queues or any high throughput output systems. Oh, Murugan and Shyam both are facing these audio issues again. Let me check if my. All right. All right. So, are you able to hear me, or is the voice breaking again? All right. The other thing you should remember is when we talk about streaming and real time, there is no such thing called real time. All right. You always you always talk about the latency, and generally if the latency is within few seconds it should be okay. Latency as in how much time did it take to process some data. All right, now, yeah, so there is no such thing called a real time system, or there's always a delay of few seconds or maybe 100 milliseconds. All right, and when we talk about streaming, the expected latency is 5 seconds, or within a second in some cases. So just a second, let me see if I can. Yeah, just a second. Yeah, maybe my neighbor. And Just give me a second, I'll check. Hello? Yeah. Can you hear? Or is it breaking now? All right. I have put internet connection parallelly, and I'm hoping that this doesn't break. So I've put. All right. So great. So I hope that is it breaking now for you? Let's see. When I maybe it will break when I talk about streaming again. When I talk about milliseconds, then it will start breaking. All right. So I was telling you there is no such thing called a real time. It is basically the our tolerance of our expectation is that within a second we should get the result, or maybe within 2 to 3 seconds or 4 seconds we should get the results. So that's what Spark streaming is generally about, or streaming is generally about. And therefore, we basically, whenever we are doing any kind of streaming, we basically convert our input data into batches. Okay, why batches? Few reasons. First, when the data is being received in real time, it's because the data is being produced by somebody in real time, right? And when we want to store that same data, we our systems, the systems which we'll be using for storage, may not have that kind of high throughput ingestion speed. Our systems, say there is our HDFS, or there is our normal MySQL database. That MySQL database may not have that high throughput, the high speed of accepting data. So you create these windows of big enough size, and then push the data into those windows. Convert the single one record into these bunch of records called windows, and you try to save each window in one shot. Okay, and you try to process the windows also independently. So the overall objective of any streaming job is to first convert the incoming data, one record per time per call, and then you basically convert the data into discrete windows. Okay, discrete batches, discrete windows. Okay, you basically convert input continuous data into non-continuous, as in bunch thousands of records together in a single set. Okay, it's like when the water is coming out from a pump, instead of considering instead of trying to handle it that way, you got thousands of buckets, and you are filling those buckets and then carrying the individual bucket. That way, you would require less number of people to handle the water. If you try to have smaller buckets, the number of people required to consume or to handle the data will be handle the water will be too high. In the same way, when your processing system is little slower, you basically try to convert the into input data into windows or batches. Right? So that's all streaming is about. So there is input data goes to Spark streaming, and Spark streaming converts it into batches of input data, and then Spark engine processes it, and then the output is batches of processed data. Okay. Now, internally, whenever the streaming is being saved, we use something called dstream. Dstream is basically a class, Spark class. Okay. Dstream is a library which converts the input flowing stream into an RDD, where the elements are ordered by time and elements are grouped into windows. Okay, so RDD at time 1 would be this, RDD at time 2 will be this, and so on. Okay, so that's what it is. Each RDD in D stream contains data from a certain interval. Okay, so we keep on creating these RDDs as and when data in batches is arriving, or we convert the continuous flow of stream into batches of data, and for each batch we keep on creating one RDD. All right, next is the general window operations. So there is a stream called, which, because if you create RDD per millisecond basis, there will be lot of RDDs. Instead of that, you try to create bigger window size. And imagine this: if your original D stream is there is one packet at time 1, one packet at time 2, and one packet at time 3. You basically try to bunch them together and create fewer windows. So out of 5 input packets, in this we have created only three windows, and each window will act as if it's an RDD, and on which we can apply various kinds of function. Okay, so we can say the way we did reduce by key on RDD, similarly we can say reduce by key and window. So per window it will be executing your function. All right. So let's have a look at this example. What we want to do is there's an input flowing data. We want to count we want to count number of words per second. Okay, frequency of words per second. So basically what we want to do is we want to do a word count on each second window. We want to execute word count on per window. All right. So we have Java stream context, where you have Java streaming context, and you basically are saying that I want to create my streaming object. Okay, dstream comes in this form. So before creating dstream, we basically create a context, and for context, the first thing we do is we just give it a name, and we say that this window is of this much size. Next is, for this context, we create a stream. So there is some service running at this port, this host and this port, and whatever is the result is going to the lines. And after that, we got lines as the D stream. Okay. Now we can keep on operating on this lines function, lines RDD, as if it's just a normal RDD or normal data set, and start distributing our work. Local is just a name. It's just a name. All right. So on top of lines, we said flat map. So if you see flat map, it is similar to what we had already done. Okay, we had already done this. So JStream, DStream is basically similar to our normal RDD. It just provides a similar kind of function. Like flat map, it just converts input into multiple keys. Next is here. So what we did was for each window, we splitted the lines into uh, multiple words, and then we took those words and apply a map function and created a tuple, just like we did just now in one of the examples. And after that, we just executed reduce by key. Okay, reduce by key, and that's all. So basically, by converting our input stream of data into RDDs, we converted our problem into a distributed computing problem by the way of Spark's behavior towards RDDs. All right, and that's what it is. So these libraries, as you see them, like Java pair, dstream, and all that, these are wrapper over what we had demonstrated earlier. And once you have counted the words in each window, you print it. Okay. And as and when the data is coming here, the data is coming from here, this function will keep on getting executed and you will keep on getting results. All right. Again, the same idea I'm trying to say. So from continuous packet of data, we had converted it all into these windows. And out of these windows, our flat map operation and group by has given us, a flat map has given us words from 1 to this. Similarly, if I have to draw this, okay, let me draw it further. Not this way. I can say full screen. Okay. So if I have to draw this, what I'll do is next will be from here, there will be key value pairs here. There'll be uh, the okay for each window, and next will be the frequency. After this, there'll be a frequency for each window, right? So after this, you'll get, when you say reduce by key, you'll get the frequency of words. All right. And here we had created from our input stream, there were, maybe there were, say, lot of words. Not, this is too big a word. So you can think of the lot of packets coming in the input, and on top of say these many records, these these many records we created this window. Okay. All right. So here basically, makes sense to you? So in my case, which I was giving you an example, in the example I was giving you, there was vendor who were pushing data to the queues. This was SQSQ, okay, and my program was reading from it, okay. So, and I was basically continuously, all the programs would do is every second read data and create a window out of it. And on this window, we were creating like, okay. So this the way I was processing earlier, as I was giving you a real life example. Okay. Parallelly, there were around 30 threads listening to it in my case. Make sense? Good. So any questions on Spark or Spark streaming right now? I will compare Spark streaming with Storm. Are you guys not replying? Okay, you are replying, but it was taking a little bit more time. All right, so good, good. The other streaming engine is Storm. Storm is the solution if you want to do processing in less than 1 second. If your window size is less than 1 second, then Storm will be your choice. Spark cannot be used in those circumstances. Storm itself is a distributed real-time computational system similar to Spark Stream, and it basically processes data, unbound streams of data, and has been benchmarked over 1 million tuples per second per node, and it can be used with any language. So, Shyam, the question would be how much time delay do you want? If per second is okay, say few seconds is okay, 4 5 seconds is okay for you, then streaming would be also a solution, and Storm will also be a good solution. Okay. But in case your demand is that you want the output in below a second, you want to create the window less than a second, then Storm will only be the solution there. Although there are other solutions also, but Storm is supposedly the fastest among the lot. The only problem is since it itself is distributed, which means you will have to set up Storm on your cluster separately. Okay. So I'll just do a comparison. Yeah. So Spark basically reliably processes your unbounded stream of data. Unbounded as in it doesn't finish. Okay. Meaning Storm will keep on continuously running. Like in this case, here, as I was giving you example, all of these processors will continuously run, meaning it does not shut down. It never shuts down. If there is no data in the SQS queue, they will all wait till the data comes in. Okay, they will all wait till the data comes in. Okay, now it also, the other biggest benefit of Storm is that it integrates with almost all database technologies, be it your MySQL, be it your any queuing systems like SQS queues from Amazon, or maybe Kafka. All right. Next is that is Storm is has been there for quite some time. It's for real-time analytics and is also sometimes used for online machine learning and is for continuous computation. And you can also do a distributed RPC. All right. And these are the various companies who are currently using Storm. So you can see that the processing model of Storm is record at a time, and Spark streaming is mini batches. The latency in case of Storm is sub-second, and in case of Spark streaming, it's few seconds. At a Storm, the fault tolerance is such that a record may be processed at least once. In order to miss out a record, Storm makes sure that the record at least get processed once. Duplicacy is okay, but at least each record is processed at least once. No record should be missed out. So the origin of Storm is from Twitter, and even before Twitter, when the company was called Backtype, till since then it has been in use. Spark streaming has been recently done, while this has been Storm is quite old. Storm is since 2011, and Spark came through 2013. So the age difference is only 2 years. All right. So you can further read the distinction between these two. Okay. So on one hand, Storm is faster, and Storm has been in production longer than Spark. On the other hand, the Spark is those it's a bit slower uh, in the terms like it will be 3 to 4 seconds. The company who is supporting Spark has been in production. Okay. Company has been supporting it full if with fully, as in case something goes wrong, you have a company to get back to. So that is another advantage of Spark. While Storm is not, in case of Storm, that's not the case. All right. So we'd like to go through a bit of NoSQLs. All right. NoSQLs, as we discussed about, is this new generation data stores. Data stores, I call them data stores. I don't call them databases because most of these NoSQLs don't qualify to be databases. Okay. The kind of definition we have carried with respect to databases, none of the databases actually qualify. Okay. So Redis is so first one is Redis. Redis is in-memory database. It's best used for rapidly changing data with a very predictable database size. When your database size is very predictable and you know that the data is not going to grow bigger than what we can accommodate in the RAM, then you use Redis, specifically when you have to do a lot of computation. Because Redis keeps everything in the memory. So if your data is smaller and you want to do a lot of processing on top of it, so probably Redis will be your choice. Okay. So as we discussed earlier, when you have to do in-memory processing, and in-memory processing is generally required in case of complex graphs of objects or in case of a complex process itself. Okay. So in all those cases, when you have a lot of processing to be done in memory on top of data, then you can use Redis. Say, for example, if you are doing some sort of processing on top of stock prices, you might want to store the real-time stock prices into Redis, okay, so that you can prepare the analytics. Leaderboards means that who has been top X players. So you must have seen when you play a game, when the game finishes, it shows you your global rank somewhere. Okay. So that is called a leaderboard. Okay. And as a thumb rule, wherever you were using memcached was also a NoSQL solution to store a lot of cache in memory. So wherever you used memcached before, you can replace that with Redis, right? Now MongoDB is good if you want to store the full objects. Okay. If you do not want MapReduce too much, although there is MapReduce, but the MongoDB is a great solution if you need dynamic queries and if you like to create indexes. All right. And as another thumb rule, if you wanted CouchDB but your data changes too much, filling up the disk, then you might want to utilize MongoDB in all those scenarios. So Puneet's question is, what does it mean by full objects? So if you remember our row in databases, our row is nothing but array of some values. If our data is complex, for example, you can see in this case, you have first name, last name, age, and address. And there is this under phone number, there is type home, and so on. So this data, if you try to store it in your regular databases, what will you do is you will create one table only for first name, last name, age, second table called addresses, and you will also create an ID for this person. Third table you will create, it will be called phone numbers. So even for this small data, you ended up creating a you ended up creating three tables, right? And sometimes imagine your Facebook profile or imagine Amazon's detail page. There would be hundreds of tables being joined together to give the results. And it is not a great idea to join all of these tables in real time for the end user. Therefore, when your object is complex and computation is expensive, preparing that object is expensive, you would like to create these objects and keep it available for displaying to the user. In all those cases, MongoDB kind of solution, CouchDB or MongoDB kind of solution are great. All right. So other is Cassandra. Cassandra is good in case you have got huge data set and you don't have, say, HBase. Okay. If you don't have Hadoop installed already, if you don't have Hadoop installed already, you might like to go for Cassandra if you want to store a lot of data and in the form of tables. Cassandra's table structure is nice, similar to what we have in HBase. And also Cassandra, the database is fairly supported by a company called DataStax, and uh, and they are quite aggressive with respect to Cassandra. Therefore, from a business point of view, it does make sense for an organization to go for Cassandra if only thing they require is a database. Okay. The added advantage of Cassandra is that it comes with a very good database driver. Not database driver, it is basically a Hibernate kind of solution called ORM solution. And there are such kind of solutions available for Cassandra. The one which I like really is Hector, Hector, which is really good which makes you feel that you are still dealing with relational databases. It does not support transactions, but it does have a tunable consistency. Okay. The other aspect of Cassandra is it has got a tunable consistency. Whether you want it to be strongly consistent or you want to have majority kind of thing, that when you are able to write to majority, then only the right is considered right. Okay. So when you're writing data, you can basically have a tunable consistency. Okay. So it also, I think, provides the transaction per row level. All right. Now, Cassandra is also quite a popular and good solution for your huge data. Now, HBase we already discussed. When you have billions of rows and billions of columns, then her HBase will be the only great solution. So, as a thumb rule, if you want your data to be like your relational data, but your data is huge, so you can either go for Cassandra or HBase. If you do not want Hadoop stack, then you can go for Cassandra. If you want, you already have Hadoop whole system installation in place, then the HBase will be a better solution. Okay. HBase provides computation via MapReduce over tables. Other thing which I forgot to mention, Cassandra provides its own query language, which is far better than what we have in HBase. Repeat what? So one thing I forgot to mention that Cassandra has got a query language. Okay, while HBase does not have a query language. Alright, HBase is used in case of humongous data, as well as if you already have a Hadoop stack installed, then HBase is not too much of load. I mean, HBase is not too much of a problem. Okay. Similar to HBase, you have Accumulo, Hypertable, and so on. All right, that was our NoSQL, and let's take a break. Yeah.
हमारे घर में मिठाई हमेशा रहता है और खत्म भी हो जाता है। आपको टीसीएस कहाँ से लगी? भोपाल से है?
टीसीएस बैंगलोर से।
टीसीएस बाहर से प्लेसमेंट हुआ था बैंगलोर से। बैंगलोर से। और किधर रहते हैं आप इधर?
वो इधर ही नेक्स्ट बोर्ड हॉस्पिटल।
हाँ? क्या म्यूट करूं मैं?
Hi, I'm back. Should we start now? All right. I think you cannot hear me. Hello? Oh, you are able to hear me? Oh, this thing is still showing me that I'm muted, and I don't know why. Strange. All right, so let's start then. It is still saying me muted, and I'm wondering what if it does not record my voice. I don't want to take that risk of restarting the audio because this thing. Actually, after a lot of comparisons, we settled down for GoToMeeting. It's recording, and these minor issues are something which basically bother me. Other than these are fine. All right, so yeah. So now I want to basically, instead of suggesting the project, I want to take you through a project and let you decide the approach. Okay. So, all right. Yeah. So, can you hear? No. All right. All right. So, yeah. Are you able to hear me clearly now? This is unmuted, and I'm hoping that uh, it should work for next 30 minutes or so. Are you able to hear me? Great, great. So, yeah. So let me just go through the document of the course. So on 28th February and session number 11. Let me open the project discussion. So this will be available for you also. You can open the project discussion whenever you want. And so the project which I want you to finish, other than the exercises for the course, please finish this project. That this will ensure that you learn what we have discussed. Okay. First is the problem statement. The problem statement is do the sentiment analysis based on the tweet's data. And this example takes you through Iron Man, the movie called Iron Man, and how do you do the sentiment analysis of the Iron Man keyword. Okay, meaning how was the how was the popularity before and after the release of the movie called Iron Man, date wise. And the I have mentioned my primitive strategy for sentiment analysis of this movie. Okay, this is a very general project, and this should help you understand the approach with respect to the sentiment analysis. So in this approach, we will be using Hive mainly, and Flume for downloading the data, and Hive for churning the data. Data I have already downloaded. Okay, so you only have to do the churning of the data using Hive. Okay, and once you have done that, or in case you want to go for another approach, the your approach will be far more welcomed. So these are various deviation possible in from my point of view. If you have more deviation from your side, please go ahead. For example, for downloading the data, somebody came up with the idea of writing the Python code. Somebody else came up with the idea that I will not basically use Flume, I'll just use Python. And somebody else said, instead of using Hive, I'll use Pig. Okay. Instead of presenting data in Excel sheet, he went ahead with the Tableau. Okay. So it's up to you, absolutely up to you. How do you want to deviate from the approach? Okay. Overall objective is to do the sentiment analysis of any keyword. Okay. So first is you can use Pig instead of Hive. You can use a different algorithm to compute the sentiment. Here the algorithm is pretty simple, and you can use basically start afresh with a new movie, some recent movie which is coming up. Use your own Flume pipeline to download the data. Create your own program to download data from Twitter, or create some other mechanism of displaying data, such as D3JS. D3JS is an open source library of visualizing the data in really innovative and new formats. Okay, and basically it's a JavaScript library in if which expects a JavaScript object, and it will load that data from JavaScript object into the graph. So you do not have to do much of a import export kind of a thing. All you need to do is just connect the data here and there. Okay, so there are many beautiful kind of graphs which are really awesome. For example, this is a polar clock. So if you have to represent the data in a polar coordinate, sometimes it becomes far easier. For example, when you're showing various sizes of the files or disk, this is a good solution. The way you use it is pretty simple. You basically create these variables, and after you've created these variables, you can feed that to D3, and you can see this. Okay. So instead of installing D3JS or something, you can directly use from their server. You can simply say here script source equals to D3 version 3. So now you'll get the directly D3 from their server. All right. So there are these or maybe Tableau or BERT. It is absolutely up to you. All right. So first step is that you log into HDFS. Okay. Locate the data in this subfolder. Right. You can see the data. Out of this, Twitter raw is the one which contains the actual Twitter raw data, and time zone map file contains the mapping between time zone and the cities and countries. Yes, basically you have to tell for a given movie, given a given movie as in fixed movie. You start with a fixed movie because You cannot be, if you build a program very generic where I feed the movie and it generates, that will be a little bit tricky to do, but it'll be great actually. That will be wonderful if you do that. And the ideas are always welcome. Okay, and then there is a dictionary that converts the each word into positive or negative. You can have a look at the dictionary. It shows that it shows that okay, okay. So abandoned is weak subject and is an adjective and negative. Okay, and ache is a verb, right? And is negative, and so on. So these are the characteristics of the whole dictionary you are given. And you're also given the tweets also here. You can go into this, and if you just have a look at any of this, yeah. So this is unzipped one. So here it is. So it shows you the tweets of every day, by date wise, and using this, you basically first compute the negative, whether a particular tweet is negative or positive per day per country. So at the end of it, you should have tweet negative. But you should have first date, country, how many tweets are negative, how many tweets are positive, and overall sentiment. This is the output we are expecting from it. All right. So once you have done that, you located the data and find out this Hive QL. The In Hive, you got Hive ddl.sql, which basically contains the query to churn the data. This is an example query. You can either use it, modify it to fit your own logic. Here, what I'm doing is I'm creating an external table on top of my tweets raw, whatever I showed you just now. Since tweets raw is in JSON format, I'm using JSON Serde serializer, deserializer, and where the object is complex, I'm using the struct. Okay, so we at the end of it, I'll get source and so on. Okay, ID of the tweet, created date, source, favorited how many times, retweeted how many times, and what was the string when what was the text and who was the user who retweeted. Okay, entities as in who was the what were the URLs in this tweet, and okay, which all users were mentioned in this tweet, and hashtags. Next is the text, actual text of the tweet. This is what is very useful for us. And then we have struct. Okay, so you can see that all of this data is part of tweet raw. This is the basic structure. Next is we load external table dictionary into this. It has type, length, word, whether positive or negative, and then stamped, as in stamped means when you append s or es or ing, that is stemming. Okay, plural word is a stamped version of the base one. Polarity, positive or negative, and so on. So you load this data using here. Here it's a plain text file, so it's a standard tab formatted, so it's easier. Next we load is a time zone map. Okay, time zone map contains time zone, country, and notes. So this we require to convert time zone into country because tweets are given by time zone to us. See the time zone here? Okay. Now, where were we? Yeah, time zone map. Then what we do is we clean up tweets raw. Okay. Clean up tweets raw to in which there is an ID, text, and who is the user. Okay. Along with the created date here. Okay, because we one time zone, user's time zone we require to figure out the country, other time zone we require for an x-axis saying on this time this was the sentiment. Okay, time zone we require for the country figuring out, and actual time we require creation time of the tweet we require for plotting the graph. Now, once you have time, these tweets clean, what you can do is uh, yeah, you got tweet simple. After that you do go one step ahead and create a view. So here from here onwards we are creating only views. So we created three base tables, all three of them were external, and now we are, just to simplify our logic, we are creating views on top of another view. Okay, so tweets clean is a view on top of tweet simple view. And what it does is basically it joins with time zone to get the country from time zone. So we got ID, timestamp, text, and country. Now our job will be to convert this text into polarity. Okay. Now if you see here, so first thing we do is we join here. Okay. No, here, that's what I was missing. So here you explode the sentences after converting them to lower such that there is one word per row. And after that you join the table. Okay. After that you join the table with a dictionary, and using this case statement you are marking each word as a negative or positive. Okay. Plus one, minus one, and zero. If you remember, neutral means zero, negative is minus one, positive is plus one, and so on. So the same way we continue further. So, okay, here we had created L1 and L2, and we then created L3 on top of it. On top of L3, we created tweet sentiment based on summing up the all polarity after grouping by ID of the tweet. So each here at this stage will get the sentiment of each tweet. Okay, after summing up all the polarities of all the words, this is what we get. Okay, so here you can change it to one more approach where you convert positive means 2 and negative means 1, or even and odd. And here you can then sum it up and then say if it is divisible by 2 then it's positive, if it is divisible by not divisible by 2 then it's negative. Okay, so basically at this stage we computed for each ID what is the polarity. Okay, and next would be to basically join this data with our, right, we save this data after joining with tweets clean for our for our timestamp and other things. Okay, because here we have missed timestamp. And once you have saved this data, once you have saved this data, then you can load this data called tweets SBI, yeah, tweets BI, using Hive. Okay, using Hive service, you can directly connect your Excel Yeah, all these queries are in Hive. So you can use either the existing data, or you can use the data which will be which you yourself downloaded. Right now I have provided my own data here. You can do your own, or you can use this one also. Okay. And for those who are curious how this data was downloaded, have a look at the Flume queries in the same way. Here, not here. If you say go to Senti and inside Hive, is it not there? Dictionary, tweets raw, not here, not here. Go to Asgiri, and under Asgiri you have Flume, you have web data, not this. There'll be a folder called Senti. Yeah. All right. I think I have kept it somewhere here only. So here, all right, no worries. I'll find it and let you know. There were some Flume things I was doing here. All right, I don't know. I think I have misplaced it. Never mind. I'll just make sure that I have put it. I'll make it available on your local machine itself. Okay. And all right. Now going back. Yeah. So we were here. So we have gone through the Hive QL. Also, before running any of the queries, do it in your own database. Create your own database and then run these queries one at a time. Okay, that will give you more confidence and understanding as in what is it doing. Try to change the approach. I'll write here. That will be the first thing. Change the approach of -1, 1, 0 to even, odd, even, and 0. Okay. Once you have done that, now after you have run all the queries, at the end of it, you will have this table containing all of the resulting data. You go through this table and figure out what data it has. After you have realized that everything is in place, now is the time to install the driver. Install the driver, install the Excel driver. So what does this Excel driver do? This Excel driver makes it possible for you to load the data from Hive directly into Microsoft Excel. Okay, from Hive. So this, after you have downloaded this, it will appear to Excel as if there is one more JDB ODBC source. Yeah, can you hear? Hello? Yeah, can you hear? All right. Yeah. So one connection was disconnected, other got connected. Again. All right. All right. Eh, fine, fine. Yeah. So once you have installed the driver in your Excel, we will have you can add your own database directly from our Hadoop one. So you don't have to install any local server or anything. This actual Microsoft Excel will directly talk to Hadoop one and get the data. Okay. So you mentioned the Hadoop one in the host. This is the Hive type will be Hive server name. And while configuring this Excel driver, after installing, just follow the steps very clearly. Okay. And the username is this, port number is 10,000, and so on. Okay. Username is student, and your password you know about. Okay. Well, your test should be successful here. While installing, it will ask you to enter all of these details. You say a test, and then once it is okay, then you save it. Afterwards, you can create Microsoft query from there itself and start loading the data and start preparing the chart. So once it is done, send me the screenshots, send me the screenshot as well as this Excel sheet, whichever you are preparing. Okay. Or or maybe you just export the data into PDF if it comes. Okay, generally people send me the screenshots that are showing me that this is the various resulting graphs. Hi, can you hear now? All right, this is bothersome. All right, so where was I when it got disconnected? I did not notice. So you install the driver. Once you install the driver, try to represent your tweets SBI table, tweets BI table here. Where is the tweets BI table? After you install the driver, just go through this document. It will tell you how to install the driver. While it asks you for various details, here are the details. Yeah. All right. All right. So I think it should go on for some more time. Is it gone? Yeah. All right. So yeah, you can configure your driver, follow these instructions. Once you have done that, present it in the Excel, send me the screenshots or maybe PDF, and that should do good. Okay. All right. So your deadlines are as per mentioned here. The okay. So the end date is 11. That's okay. Not this one. This is not yours. I've opened a wrong one. Yours is 21 February. The deadline is April 14. The end date is April 4 today. Project start date is today. And assignment date is April 11. Okay. So assignment, please submit all your assignment before next Saturday or next Sunday actually. Okay. And yeah, and submit your project by April 18. All right. And after that, we will be giving you certificate on April 25th. April 25th. In that certificate, you can display it on the LinkedIn as well. Okay. Now, LinkedIn honors our certificate, so you can display that there. And yeah, all right. So if you have any questions, feel free to reach out to me. All right. Any questions? Do you want to discuss something? We have some time still. We have uh, 45 minutes. So if you have any questions, you can reach out to me. Yeah, go ahead. How to do capacity planning for Hadoop projects in general. Okay. So the capacity planning is generally done in two ways. Okay. So generally most of the capacity plannings which I have done so far, they involved understanding the current data, period of the data, mean to say that period of the data for future, for how long. Third is the data growth. Okay. Okay. And the center to the whole idea is to the whole data whole idea is number of users. Okay. So based on these criterias, you figure out how much how what will be your data size after some time. Okay. After that, as a thumb rule, keeping 200 GB per machine. Okay. I'm not saying that only keep 200 GB as storage. Per 200 GB of data, minimum, or maybe 100 GB based on how big is your problem. Per 100 or per 200 GB, 100 to 200 GB, have one node. Okay. If you have 1 TB of data to be processed, okay, you generally have 10 nodes. Okay. It's not because this data cannot be handled in a single machine. It is just because the data accessing will be really, really slow. Okay. On a single machine. 10 nodes. Okay. And you always keep a fault tolerance of minimum 20%. Okay, minimum 20% fault tolerance. Okay. After this, if you see, you have 1 TB of data and you have 10 nodes, and probably actual hard disks you will have is around 10 terabytes. Okay, so yours basically 1 TB will become 3 TB, and still you will have 7 TB space left. Okay, if you have 1 petabyte data to handle, you might require 10,000 nodes. Okay, so this is how you generally do a computation on the data. uh, Based on data, you have this kind of computation. All right. So this is Hadoop cluster planning, and okay, and this computation you should do it very very cleanly. Okay, you should do it. You should figure out how is your data access pattern is going to go, and current data, and this data growth you should always consider something like 100% growth over a period of 1 year. If you are handling, your plan was to handle 1 terabyte this year, next year your plan would be to handle 2 terabyte, twice of what you handled this year. Okay, that means by the end of next year you will have 3 terabyte of data. Just give an example. Okay, so after you have done that, the other part is you should have the name node should be having a good amount of RAM, and you should have a secondary name node, and afterwards the data node and everything is can be anything, can be any smaller node, or doesn't have to be big RAM node. And next comes as in, when you have set up this cluster based on a rough computation, next will be the job wise computation. Okay, so every time one of the teams is coming up, this is the initial planning, some initial planning. Next time, every times one of your teammates will come up and say that, hey, we have got new use case and we want to develop this application on Hadoop. Okay, again you will ask them the same question: what kind of access pattern do you have? Okay, and if you had your own machines, how many machines do you require? Okay, so based on that, because most of these systems are fairly linearly scalable, as in if you set up from the scratch, then also you would require that many machine, or if you have available that much of capacity, you can devote that capacity. Okay, so there you will have to figure out the capacity the user is asking for. If it is available in your current infrastructure, you can give it to them. Okay, so that's a general overview of doing the computation, doing the capacity planning. All right. Now Shyam's question: what are the blogs, forums, groups, etc. that you recommend to stay top of the latest happening in the big data area? Okay, okay. So I'm generally following, one is Google's big data blog, if you have been following it. Second, I am following Hortonworks and Cloudera. Okay, their blogs are really nice and useful, and there are a few data scientists I'm following. So you may also like to forums. I don't know much which forums are great, but the blogs of Cloudera, Hortonworks are good, and even Google's blog is really good. Okay. So yeah, Murugan's question is any idea about Docker with respect to the big data and Hadoop? Yeah. So lots of people are using Docker to install Hadoop whenever they have to provision machines. They're using Docker instead of a full thick virtual machines. They are using these lightweight virtualization tools. Those are pretty nice, and I'm sure that those are going to grow really big. Okay. And yeah, because based on the feedback I have received so far from people, they're pretty happy with the Docker images, and I just want to see that if I can also try out Docker images on top of our cloud labs. Okay. So for those who do not know what is Docker, Docker is basically a quickest way of creating the instances of a service, instances of the full solution, basically a provisioning system. Okay, you create Docker images, you deploy them on multiple machines. All right, so feel free to ask any questions now, because this I would like to keep it a little bit more formal. Yeah, so Mugan's question is, he while programming in Java, he could see similar classes in both the packages, MapRead and MapReduce. Hadoop MapReduce star versus Hadoop MapRead. What is the difference? Any idea? So the difference is with respect to Hadoop version v1 and Hadoop version v2. Okay. So I'll clearly document this. I'm just taking this note and I'll clearly document it and put it on the blog as well, or forum as well. Okay. So try to be active on the forum. Okay. And any questions, I'll be answering your question. I'll be also putting it here. Okay. So yeah. So these are the few questions. So you can also try to answer here. All right. Yeah. So yeah, Prithvi is asking about high level info on Splunk. So earlier also I was telling you about the way Amazon maintains their server. So probably I can tell you from that example. You would like that one. Let me explain that. Yeah. So so when you have these kind of websites, you will have thousands of engineers parallelly working to looking after the server, all the servers, and say the Amazon's website. So the moment we get an error, we get an error in the website. If that error is accumulating, that means there is something wrong with the website. Okay. So in case of Amazon, we gathered on the server side both the logs from the JavaScript, because JavaScript keep on throwing errors here and there. So we kept on pushing that to server side. as well as the server side logs. Okay. Now, on the server side, we have these great amount of information and logs about the current servers. All right. Now, in real time, if you have to do an operation management saying if an error is being repeated more than 20 times, then cut a ticket. Then, if a particular error is being uh, has been occurring for last 5 minutes, and these many times, create a ticket against a particular team. Raise an error ticket against a particular team. That way, if you raise that ticket against a particular team, you will that particular team will immediately look into the error. Now, to be able to do so, you should have a central log management system which can quickly search, which can quickly aggregate and search. So Splunk is one such solution. Although what Splunk does can be done using Flume, but Splunk comes prepared with that kind of models. Okay. So I hope that cleared, gave you a clear answer. No? So in real time, when you have a web server, you want to do all sorts of log churning, because in real time, when the website is running and there's some error has been occurring, users will start complaining after some time, till the point you will already have lost a lot of business. You want to do a lot of risk mitigation, and in case you are running multiple servers, looking at logs is next to impossible. Similarly, even if you have one server, looking at logs the way it's a plain text file and all of that, looking at it is impossible. Okay. So you built a lot of automation saying, in case error keyword has been occurring many times, then launch this, launch that, and create a ticket, and so on. And also, you provide these great tools to the end user saying, on this tool, user can come and say, group by a particular URL. So it will group all that by and tell you that in this kind of error, this URL is being repeated that many times, this URL being repeated that many times. So that will give a very clear indication. Also, you provide other kind of tools such as browser header, which browser is causing this error and that error. Okay. So Prithvi, did it make sense to you? So because if you don't have these tools and your users are going through log files continuously using tail and vi, and imagine that there are thousand users coming to your website, each user is creating say 1,000 log entries. Every incident is creating 1,000 log entries. So 1,000 into 1,000 is 1 million line per second, over few hundred servers. Then you are going to have a very tough time, okay, to actually handle the errors. So one is like passive churning of data, that tomorrow when or maybe next year we'll churn this data and figure out some very valuable insights. Other is r- in the real time, what is the error we are facing, we need to look at the logs and sort it out. So for that you should have to, like, given a keyword, it searches all of across the logs. Given a particular field, it groups the data by that in that time window. So those kind of things can be very well done with this Splunk. Now, coming to Murugan's question, I know that this, okay, I know this is a bit basic question. It would be really great if you could provide live example scenarios for using all these tools we learned so far. When to use what kind of summarizing. Okay. All right. So yeah, let me answer that first. Let me take a note of this one. And yeah, next question is. various tools. Okay, the first one was HDFS. We all know that. So whenever we are storing data of humongous size, or I think I'll just answer quickly Prithvi's question. Is Splunk for logs only, or is it good for other big data also? It may be used for other big data, but the design has been mostly log centric because the features it provides you are very log centric. Okay. Now I'll just go through. So when HDFS is for storing big data, and this is the first step. Whenever in an organization, the first thing you should immediately do is set up an HDFS and start pushing the data. Okay. Next is MapReduce. MapReduce Java. So whenever you have to do computation for which Hive, Pig can't be utilized. Okay. Use Java if you know Java. Else use streaming. And if you know, or if the input split need to be customized. All right. Next is Pig. If you are starting an analytics project from scratch, use Pig. Else, if you already have lot of queries, already have lot of SQL queries, use Hive. Okay. Then you have HBase and Hive. You got the answer right. Pig and Hive. HBase, if you have billion rows and million columns, or you can say 100 million rows, 100 million rows and columns, you use HBase and need frequent editing. Then after HBase, we talked about Zookeeper. Just coordination, storing very small data for coordination. All right. You use Mahat for clustering and classification in machine learning. Okay. Next is Flume, one-way flow of the data without any processing involvement. Spark, alternative to MapReduce for computing. good if the is data fits in RAM. All right. Now you have okay, scoop in and out SQL. Now after Spark, so Storm streaming. All right. So to store the data, if your data is going to be in terabytes, it would be a good idea to push that to HDFS. If you are building a tool which is going to dig insights on top of your data, so you can do it either in MapReduce, Pig, or Hive. Okay. If you want to dig into the data at later point of time. If you want to dig into the data in real time, you go and use Spark. Okay. Next is in case you want to edit the data continuously at a faster pace, edit the data. You already stored it, you want to edit it now. Then you go for HBase or you are, yeah, hello. Any better? No. All right. So I hope that gives you an overview. And there was one more question. How Hadoop cluster backup and disaster recovery being done? Okay. Yeah. So this is a little different from our traditional question. Okay. So generally, generally in older system, we had a separate cluster backup and disaster recovery being done. All right. Here, we do not generally create a separate redundancy other than the cluster. Be it MongoDB, be it Hadoop. In both the cases, wherever we want to keep the backup, we keep it in a remote location but connected to our existing existing cluster. Okay, that way our data is safe. Maybe it's in another location, but it is safe. All right. So we generally add the backup nodes into the cluster itself. And these backup nodes will keep the data backup of all the whole node. And if required, we can basically build our own systems and processes such that we keep the history of each file as well. Okay. Same case is with MongoDB and other kind of systems. The backup node data, when the data is kept on the backup node, we I mean, instead of creating another set of cluster where the copy of the data will be kept, we basically keep one machine which is far away and make sure the data flows to that one also. Okay. Although there are good Hadoop cluster backup and disaster recovery tools, and okay, provided by various vendors, I'll just mention you later on. Okay. I'm taking a note of this one. Yeah. The next question is, what is the standardized break-even period point for what is the standardized hmm. So it's more of a business question. It's not like setting up a restaurant. It's more of a business question. Okay. So for some, the ROI is realized the moment they are able to store the data. They are able to store the data. For some, the ROI will be ever going process because ROI is a function of the data engineering and the vision of organization. Okay. So unlike saying that a restaurant, we are setting up a restaurant, we'll run it for some time and it will start giving the returns after this time. Instead of looking at that way, we basically look at it from a point of view of first uh, two phases. First, the initially the moment we are able to store the data and our usual computations are started, then first return has reached. Second is, the more engineers you hire, the better engineers you hire, the more visions you come up with, the better would be the usage of your Hadoop. Okay. The other thing is, the other part is also understanding what do we mean by investment. Investment could be investment could be hardware. Investment could be people who has been trained or hired, right? And investment could be the software and contracts, right? So the good news is that hardware, software, and contracts is fairly low cost as of today. It's only the people which is on the higher side. Okay, so overall, actually, the investment is going to be smaller, and probably that should be recovered as soon as you are creating a cluster. Okay. Next is you can keep the I part very low from the beginning. Okay. So what you can do is you create a basic cluster. Okay. Very basic cluster, and let and increase the investment as the returns grow. Okay. You set up a smaller cluster and and then do the engineering, hire engineers or build the team, come up with various kinds of use cases of the data, come up with the sources of the data, and that should give you a clarity of thought on whether the returns are coming on the investment or not. If returns are coming, you will automatically increase the investment and then get the returns. Good news is investment can be very low. It can be as low as 5 lakh rupees. Okay. No, these are good questions. These are good questions, and I'm hoping that others will also face these questions later point of time. Specifically, capacity planning is something we all do and we all should do. Okay. Yeah, makes sense to all of you. Should I move on with the for next question? All right. So keep your investment low in the beginning, and as you grow, as the data grows, you keep growing it. All right. Any questions? Yeah, I forgot to mention the Uzi part. Uzi is to create the workflow, tie things together. What do we mean by creating workflow? Tie various things together, or you can say connect various things together. Connect various processes together, such as download data from web, then upload it to HDFS, run Hive queries, and so on. Okay, and runs on the server, and you can schedule it. Okay, you can schedule it. Yep. So now Murugan's question is, what about data security in Hadoop? Okay, there was, yeah. So most of the components which are part of Hadoop are very good with respect to Kerberos. So HDFS, MapReduce, all of these tools honor Kerberos. Okay, so basically, when you honor Kerberos, you assign the users and let them access the system. Okay, initially these systems were not designed as multi-user. They considered that all the machine in the network which are connected there is no security and issues, and earlier that was the problem, but now these are fairly enterprise level, and the general enterprise level security is in the form of Kerberos, not NTLM not NTLM or Active Directory, but Kerberos. Although it should not be a problem to move to NTLM. All right. I was trying to answer, yeah. So yeah. So you generally don't encrypt the data when you put it on HDFS, though you zip the data, which is compress the data using LZO. Okay, but you don't generally encrypt the data. In case you encrypt the data, the whole purpose of HDFS is lost. Okay, and every time you have to access the data, you have to first load the whole data and decrypt. And most of the encryption decryptions are costly affair because encryption itself, if you think about hashing or decrypting something, the algorithm, because it's difficult to guess the password or decrypt without knowing the password. Cracking the algorithm is fairly difficult just because it takes a long time to guess things, right? So that is why most of these algorithms take a considerable amount of time. Think of hash function. Hash function takes a considerable amount of time. Okay, so you generally don't put the data encrypted on HDFS. The If you are worried about user information, okay, so what you do is you generally hide the fields or remove the fields containing the sensitive information. Okay, imagine that you are storing the data of a e-commerce site. So you generally divide the data into three sections. One is First part would be the most serious one, which will be the credit card details. Those tables, that data is not accessible to anyone. Okay, only some people would have that information, and that data will be heavily encrypted. Okay, the data will be encrypted. Second label would be the name of the users and their addresses. That is second level of confidentiality. You would like to encrypt that data, that's your choice, but these are separate people have separate accesses. Now you will convert this username into an ID, and the rest of the information about the user is under the ID. ID as in this user visited a website. So instead of saying Sandeep Giri visited a website, you designate a random ID to it, random ID to Sandeep Giri, and that's how. So basically, whenever you're dealing with big data, instead of saying that I'll encrypt whole data, which is not sensible, you part of the data, you basically categorize your data into parts. Okay, you create three labels saying level 1, level 2, level 3, and masking. Whenever you hear this word called masking the data, it essentially means you remove the name of the users and other serious information which can lead to the exposure of the username and user's personal detail. So you remove all of that and you just replace it with a single ID. But sometimes age age and gender, you want to keep it in the table so that you can do a various insights. All right, so that is how generally the things are done. What about production support processes for Hadoop project? Is it similar to other standard web projects? Production support, yeah. So production support, basically you have to have teams in the production, but most of the way we have looked at Hadoop processing is that in case Hadoop is not working, nothing is going to hurt right away. We may get hurt tomorrow, but it's not serious. Okay, the TAT will not be too high. It all depends from organization to organization, but TAT will be relatively low. TAT is in turnaround time, relatively low as compared to your normal website. Okay. If you are running a real time tools where the user is getting the real time information from your systems, say part of the analytics, Google Analytics, one part shows you the real time user behavior. Okay, so if this real time is being computed on your Hadoop cluster, then then you need to be really worried about it. So in cases the real time, we generally create the different machines for real time computing and non real time computing. The reason is the production support. Okay, even if tools are same, the reason would be production support, because for real time customer facing application you will have to have good production support team. Yeah. So I hope you got the answer. These are very good questions and these are very real questions. Okay, I would try to post them on to, or if you have time you can post it on our forum, or maybe try to answer, and some of you can try to answer on the forum. I'll also try to answer. Okay, please be active on the forum, and that will be a good way of staying in touch with the technology. Okay, you can just click on the menu and click on the forum, and then yeah. All right. I hope I was able to answer your questions. And in today's time, it does not make much sense to say goodbye because, yeah. So, okay. Now my phone is reachable generally, so you can reach me on the phone. Hello. Is it audible now? Not yet. Is it audible now? Yeah. Okay. It's breaking still. All right. All right. So, yeah. So you can reach me on my number. You already have my number. All right. And if you have 919538998962, so this is my personal number. And the number displayed on the website is from sales guy, and they can answer your queries related to the further courses. And if you have any technical question, you can give me a call, or email would be a better mode because that's when I can settle down and answer things properly. All right. So stay in touch. Send me a LinkedIn request, and that's how we can stay connected. In today's time, it does not make sense to say goodbye because we are anyway connected. All right. So if you have any questions, let me know. If you have any friends who is interested in these kind of courses, you can connect them. And if you have any other questions, queries, or something, you can get in touch. All right. Okay. I'm happy, Morgan, that I have got a great team. And so now there is going to be a noise. I'm going to unmute everyone. So everybody is unmuted. All right. Bye bye then. So can say bye. I hope you are not in noise. I have unmuted everyone.
Yeah, hi everyone.
Bye bye.
Thanks, Sandeep.
Okay. Have a good time.
Thank you, Sandeep, for your valuable training. And
Okay.
Murugan's questions were very good, and your explanation was too good. I did not expect you would give so much big explanation about those basic question which you actually thought, but it was a nice explanation there.
Okay.
What
Um.
are the types of usages?
Okay. Okay. Yeah. Thank you.
All right.
I'm happy
Thanks,
that I
guys.
was of help. Yeah. All right, Shyam. Thank you. And
Thank you. Thanks, Sandeep.
all right.
Bye, guys.
Thanks, guys.
Okay. Bye bye.
See you.
See you. All right. All right. This is a little noisy session, part of the thing. Okay. Okay. See you. And stay in touch. Stay connected. And yeah. Bye, Chandra. Bye, Roshan. Bye, Sham. Bye, Prithvi. Bye, Puneet. Bye, Morgan. Have a great day. Bye, San. All right.